Alright, this question uses a lot of identities. So if we look at sine 3 theta, so we're looking at this, the left-hand side of the equation, we can certainly break that up if we have a look at what we want. We want all single angles. So let's start by breaking it up into sine theta plus theta and expanding that. So we know that goes sine 2 theta cos theta plus sine theta cos 2 theta. Now we also can take note that everything's in terms of sine in that right hand side, so we want everything in terms of sine. So again, using an identity for sine 2 theta, we know that's 2 sine theta cos theta, and then that would give us a cos squared theta here, because you've got cos theta times cos theta, and here we've got a cos 2 theta. Now again, cos 2 theta, one of the identities for it, I want the one that gives me sine, so that would be 1 minus sine squared theta. So I think you've got something, yeah, you've got something like that on the formula sheet somewhere. Or is that one of the ones you have to remember? So remember how just to expand out cos theta plus theta using compound angles, and then using the fact that cos squared is 1 minus sine squared and sine squared is 1 minus cos squared, and that will get you there. So don't forget to keep practicing that. Alright, so, and then we know that cos squared is 1 minus sine squared here, so again, using an identity, and here I might expand out. Alright, so once more expanding out here, this bracket, and we've got that there. So all together, if we have a look at, they want the sines first, we should be getting 3 sine theta, which we do, and we should be getting minus 4 sine cubed theta, which we do. Alright, so that's our right hand side. So that's fine, we've proven that is true. Alright, so now it says hence, so clearly we're going to use that. So hence we want to solve this equation. Alright, so we know that sine theta equals all this. So this here, my left hand side. Actually I'm solving, so I'm not even going to do the left hand side. So for sine theta I'm going to sub in what we just proved, because it's a hence, and they're saying plus sine 2 theta. Again, that's a double angle, and I probably want everything in single angles because everything else is single angles, so I might do that straight away. 2 sine theta cos theta is the identity for that, and that equals sine theta. So if I put everything on one side, I am going to get, actually I'm going to think about putting everything on the right hand side. So I'll make this a positive. So I'm going to get sine cubed theta, and then I'm going to look at the sine thetas, and I'm going to get a negative 2 sine theta, because this will become negative on the other side with a positive 1. And then I'm going to put this on the other side too, so negative 2 sine theta cos theta. So I've still got that cos theta, which is a bit annoying. Alright, so in order to get rid of that, well, that's okay, because maybe I can take one of the sines out of that sine cubed, and then I have a sine squared that I can make into a cos squared to join with that. So all three terms also are divisible by, or they have a factor of sine theta, so that is handy. Not only that, they have I think, is it worth it putting a 2, dividing through by 2 as well? So let's cheat a bit. So let's divide everything by 2. Alright, so I'm going to have sine theta outside of 2 sine squared theta minus 1 and minus cos theta. Alright, and remember that sine squared theta is 1 minus cos squared theta. Hopefully this is getting us a little bit closer. And so here we're going to have 2 minus 2 cos squared thetas, minus 1 minus cos theta. Cool. All right. So what do we have here? So negative 2 cos squared theta. Then we have a negative cos theta, just trying to put it in some nice order, and a plus 1. So again, if I divide by both sides by negative, I can change that to a 2 cos squared theta plus a cos theta minus a 1 equals 0. Now I'm hoping I can factorize that. So that's a prime, so that's nice. That's also a prime, so it's got a 1 and a 1. I want a positive in the middle, so I want a plus 2 and minus 1 gives me positive 1, and it still gives me the product of negative 1. Alright, so that works nicely. So you can see from that, if I'm solving, I either want sine theta to be 0, or I want cos theta to be a half, or I want cos theta to be negative 1. So they're all the things I need to solve for. Alright, and we are going between, I guess, 0 and 2 pi. So sine theta is nice and easy. We've got pi and 2 pi. And 0, don't forget your 0. Alright, so far what I've got, okay, you may need to pause and just make sure that part's okay. So far what I've got for sine theta equals 0, we're going to get theta equals 0 pi and 2 pi. And then for cos theta equals a half, so remember for cos, all stations to central, we are looking, it's positive, so we're looking in this quadrant and this quadrant. So the acute angle for half, remember, is 60 degrees, so cos 60 is a half, which is cos pi on 3. So I'm just going to add it here. So we've got pi on 3, but for this quadrant here, this would be 2 pi minus pi on 3. So if I want that on 3, I'm going to make that 6. So 6 minus 1 is 5. So I've also got 5 pi on 3. Alright, and then for cos theta equals negative 1, I have to think of the cos curve. Negative 1 only happens here, which is at pi, and we've already got pi as one of our answers. So we should be getting 1, 2, 3, 4, 5, 1, 2, 3, 4, yeah, 5 answers there. Alright, so they would be all the solutions.